There's an I in it. That's called complex. Okay, pay attention now. If I go up to that last problem, this says all real numbers. What does all real numbers mean? It has to be on the x and y coordinate plane. But this is complex. Okay? So, anytime you get an answer with complex, your answer is going to be all real numbers. How would you write that in integral notation? Negative infinity to positive infinity. Let me explain why. Let's think about it. If you pick a positive number, someone pick a positive number. Okay, 2 is going to represent all the positive numbers, okay? 2 squared is, and 4 plus 4 is, and then you can divide the fraction. Does that make sense? Okay, let's pick a negative number now. Someone pick a negative number. Negative 2. Oh, I have to point this out because negative 2 squared is not equal to negative 4. I'm pointing that out because multiple students got that wrong on the last test. Okay? If you're confused, put it in your calculator and use parentheses. Negative 2 squared is positive 4. Wow, this calculator can help me? Awesome. So think about it. Any negative number you square turns into a positive, and a positive plus a positive is still positive, which means you can pick any real number. You can pick all numbers. All real numbers is your answer. So class, anytime it's complex, what do you put? All real numbers. Okay? Alright, last example. Okay, in this problem, you should put your finger here to start. Right? You're basically taking that. And how do I set it up, class? How do you set it up? Not equal to 0. Did I copy that right? It's plus 5. Okay, we got a factor. A times C. B value. Two numbers I'll multiply to be 10, add to be negative 11. 10 and 1? Which one's 10? Which one's negative? They're both negative. Okay, pay attention. It happened last period. A student told me, Mr. Ring, the answer is parentheses x minus 10, x minus 1. Is that right, class? No, what do you have to do next? You have to do the box. Negative 10x, negative 1x, 2x squared, positive 5. Class, what's the greatest common factor? X. How about this direction? 2x. Okay. Remember, if you don't know, x times 2x gives you 2x squared. Yes? 2x times something equals negative 10x. Negative 5. Right? Multiply those, get it? And then over here, greatest common factor is negative 1. Negative 1 times x, negative 1x. Negative 1 times negative 5 gives you positive 5. So my answer is, in factoring, 2x minus 1, x minus 5 is not equal to 0. And then, remember, pretend this is like an equal sign, so you would just use 0 product rule, but in this case we're going to do 2x minus 1 not equal to 0. X minus 5 not equal to 0. I'll add 1 to both sides. Divided by 2, x is not equal to 1/2, and x is not equal to 5. How would I write that in set builder notation? you can do all values of x such that x is not equal to 1/2 and x is not equal to 5. Okay, here's a crazy one. Ready? How would I write this in interval notation? Well, you have to visualize left to right. I'm going to start at negative infinity, and the first thing I'm going to touch is 1/2. Don't include 1/2. Go to 1/2. All the numbers up to 5. Don't include 5, and go towards positive infinity. Alright, to summarize, to find the domain of a rational function, you're trying to think of values of x we don't want, so we just set it up not equal to 0, and then you can show your answer in two ways, either set builder notation or interval notation. Alright, let's go over these three examples. We need to write the domain in set builder notation. Put your finger on an example A. Where do we start? Put your finger there. You should have picked this, right? Basically, we're going to set this, what? Not equal to 0. Everyone say that. That's today's lesson. It's easy as that. Can you simplify each day's lesson in one sentence? So I'm just going to add 1. I changed my x to t's. That's okay. 4x is not equal to 1. And then we're going to divide by 4. X is not equal to 1/4. Or if you want to go back, just make your x t. Alright, what's set builder notation? Set builder notation is basically, you just put a, I'll try to do this in different color. You just put a bar right here. You put your t or x, and then you put these fancy brackets. This is set builder. We've done it before. What does it mean? It says all real values of t such that t is not equal to 1/4. Okay, now let's just say I asked you to put this in interval notation. Well, you can give yourself a quick visual. It basically said pick all numbers except for what? So that would be an open circle. Does that make sense? And then your arrows are going this way and this way. So if you had to write this in interval notation, what would you say from left to right? Arrow, which is what? Negative infinity to 1/4. Don't pick 1/4, that's why it's a parentheses. Union with what? 1/4 to positive infinity. This is just, so if I ask you to put it in interval notation, your answer would look like that. Or if I ask you to set builder notation, it's basically your inequality, and then you just put the bar and then the symbols. Okay? Let's jump down to example C. We'll come back to example B. If I want to do C first. X over x squared plus 4. Put your finger where we're starting. Class, tell me what to write. Not equal to 0. So if I'm trying to point it out to you with special colors, you should do the same thing. Okay. How would you solve this? There is no b value, so are you going to factor? No, we're going to use the square root method. Subtract 4, because I have both an a and c. I have x squared is not equal to negative 4. What do you do next? Careful, go. X is not equal to, you took a square root of an equation. Plus or minus. No, that's not the answer. The square root of negative 4 is the square root of negative 1 times the square root of 4. Class, what's the square root of negative 1? Square root of 4. Okay, pay attention. Is this real or not real? How do you know it's non-real?